Okay, this is the AP Grade 11 class, and tonight we're going to look at completing the square. We're busy with solving quadratic equations, and we are now looking into how can you solve an equation that not necessarily has any factors. Okay, now I just want to in general let us talk about this quickly. So if I have x plus 3 squared, okay, alright, if I have x plus 3 squared, then we know the answer should be x squared plus 6x plus 9. Okay. Alright, sorry, I'm running out of the space there. So the important thing that I want to show here is that x is squared over there. This one is double that one. And this one squared, okay, I must just remember to come down here. This one squared gives me the 9. Okay, so if I start in reverse, that's the important thing to understand. If I now start in reverse, in other words, if I have x squared plus 6x plus 9, then I can make it a perfect square by taking the x without the square, like I had there, the same symbol here, like I had there. This one I must divide by 2 to get the 3, and then I'm done. Okay, so say now we have x squared plus 6x plus 8. Okay, let me just remember now to come back here a little bit. Okay, plus 8. Okay, so if I now do x, the plus as it is, and half the 6 squared, okay, I'm going to have this x squared plus 6x plus 9. Now to get from there to 8 there, surely there should be a minus 1 to get to the 8 here. So what we must then remember is this plus 9 is part of this square. This 3 squared is going to give me this 9. So in other words, I need to subtract that square if I have my plus 8 over here, so that I can get back to that minus 1 that will bring me back to 8. So my answer will be x plus 3 squared minus 1. You see, because the bracket squared is going to give me the x squared plus the 6x plus the 9. And then the minus 1 will bring me then back to the 8 there. Okay, so if we understand it, then completion of the squared is not so difficult. It has to do with subtracting that square in the end. Always subtract the square. And I like to group my trinomial into pairs of 2. The schools do not do that, but I find this to be a lot easier. Okay, but that's the important thing. Let's just go to the next page in the note here. Alright, so yeah, I also want to show the solution here, the solving to 0 here, but I first just want to make use of, let us just use the same thing that they have there, but I want to show you a very important difference. Okay, so if I have x squared minus 6x, okay, plus the 1 there. So now you have, you don't have an equation here, you have an expression. So, or you can also say you have something like, and y is equal to, this is not an equation, but I mean, you don't have equal to 0 to solve in this case. Here, we have x squared minus 6x plus 1 equal to 0. Alright, but not here. So this is just an expression. Okay, so if I rewrite this now so that it is the same thing, remember I cannot change it now, I need the same thing, then I group those two together, and as I say, they're going to give me the square. They're going to give me the square, and then let's keep that plus 1 there. So this is the x without the square, the same symbol, then half that one, and then subtract this square, so minus 9. So we always subtract the square. So now this is going to give me now x squared. I'm sorry, it mustn't be x squared there. It must just be x minus 3 squared, and then this is minus 8. Now the minus 9 and the 1 is minus 8. Now we all know now that that is giving me most the x squared minus 6x plus 9, and that 9 minus that 9 will give me the 1, plus the 1 will give me the 1, or x squared minus 6x plus 9 minus the 8 will give me my 1 back. So this and that is now exactly the same. That and this is the same equation, but this is in the form of a square, where that one is not. And this is why we call it the method of completing the square. Now the reason why we do this is that we have a property in maths that if we have a square equal to any number, we can then solve it by taking the plus and minus the square root of the right. So x will be plus and minus the square root. We all have done that, so that should be familiar to us. That should not be a problem. Alright, so if I can rewrite a number in a perfect square form, then I know I can solve it. So in other words, if I have this now, and I want to solve this now, okay, then I can rewrite that number, or that expression now, in this form here, in the completing the square form. So I know that is the same as x minus 3, let me just get the brackets right, x minus 3 squared minus 8, you see? And now I can move the 8 to the other side. And I have x minus 3 squared is 8. And now I can use this property we just talked about here, that we can always take plus or minus the square root. So I can now say x minus 3 is then plus or minus the square root of 8. And then I can move the 3 to the other side, and I have two solutions here. 3 plus square root 8, or I can have 3 minus square root 8. I can also write 3 plus minus square root 8. That doesn't matter. The point is I can find the two answers for x here. And that is the reason why we do completing the square, because we can write any trinomial we can write in this form. Therefore, we can solve any quadratic equation. Now, this is a quadratic equation, quadratic equation. So we can solve, this is an expression, this is an equation, quadratic equation. So we can solve that by rewriting and use the square property, the square root property or the square property to find solutions. The others that we did previously, prior to this, we could only solve when we had like factors. If you can factorize it, then we could solve it. And the ones that actually have factors are very few and far between. So we're going to have a lot more like irrational and so on that we cannot find factors for, and therefore we need a method to solve those equations. And one of the methods is not the only method, but one of the methods then is to do it by completing the square. So let us look now on the next page. Okay, let's just look here at number B here. Make it a bit bigger. Alright, so what is important now is when we use completing the square, we need to have a 1 here. There we have a 2. So first of all, we must divide by that 2. Okay, so we're going to have our 2x squared plus 6x plus 7 equal to 0, and we need to solve this now. Okay, now if you can find factors, of course you're going to use factors, but don't waste your time on factors if you have this method where you can go directly. So for completing the square, we're going to divide by 2, and we're going to have x squared plus 3x, and that is 7 over 2. Okay, now we have what we have there on the left hand side. Okay, now we're going to rewrite this into the completing the square form, in a square form. And for that we said we group the first two. X is just like that, the plus is just like the plus. We divide that 3 now by 2. Okay, and then we minus that square. That we now know. We must always minus that square. So it's going to be 9 over 4, because 3 squared is 9, 2 squared is 4. And then of course we have this plus 7 over 2. Okay, and then now we move those two to the other side, and then we Okay, so we move that to the other side, we get negative 7 over 2 and plus 9 over 4, which is going to give me minus 5 over 4. Now we can do the square root property, where we take plus minus the square root. Of course, we get a negative inside, which is imaginary. We will come back to the complex numbers a little bit later, so we can give this as complex answers. But at the moment now, for our knowledge at the moment, we will say there's no real solutions. We will say they're non-real, or there's no real solutions. Okay, so nothing to worry about. We make sure that we have a 1 in front, and we rewrite the trinomial in a, sorry, that should have been a square then. We rewrite the trinomial in a square form, and then we sit with this, and we add those two, we move those two to the other side, we add them, and we apply the property of taking the square root with a plus minus. Okay, and we can solve them. So if we look at C here, we've got a 3 in front. We don't want that 3, so we're going to divide by 3, and then we're going to, there's now the trinomial. We're going to change that now into a completing the square form. If we change the page here, all right, then we will find that's what we did. So let us just look together here. So we had Let me just copy the previous, just go one page back just to see again. Remember we had x squared minus 2/3 x minus 1/3. X squared x minus 2/3 x minus 1/3. Okay, so we had x squared x x squared minus 2, not square, x squared x squared minus 2/3 x, and we had minus 1/3. And that is the trinomial we want to solve now. So these two, you can move the third now to the other side, that's why it's now there. But I just want to keep what we've done together. So I'm just going to say again, we take the x as it is, we take the minus as it is, and now we do half of that one. Now 2/3, half of 2/3 is 1/3. So 1/3, then we square, and then we minus the square of this one, which is going to be 1/9. So we minus that, and there is our minus 1/3. Remember, this comes out of the 2 there. The 2 there gives us this. That minus 1/3 is still there, equal to 0, and then we move those two to the other side, and that's going to give us the 1/3 plus a 9 on the other side, and then we're going to be here, because 1/3 plus a 9 is 4/9, and then we take away the square by applying the plus minus square root property, and the square root of 4/9 is 2/3. So in the end, we can move the minus 1/3 to the other side. So therefore, our x is just going to be the 1/3 plus or minus the 2/3, and we are done. Okay, so that is how we complete the square. If we move to the exercise at the back and we look at some of these questions, then you'll see here, solve by completing the square. So sometimes we ask it directly like that, solve by completing the square. But often it will just be solve for x, and you will realize that you need to complete the square. What I just quickly want to do is to do one similar to this now. So now x squared, you can get something similar to this. Say px there, and say plus 4, just like that, equal to 0. So how do we do that? And this is the key about mathematics, and that is that if you understand a rule, then you need to be able to apply that rule in all circumstances. Okay, so we have the 1 here, so we're going to use those 2 again to do the square. So how do we do it? The rule says you take the x as it is, the plus as it is, but now you must take half of that middle one. So that should be then p/2, and then you must square it, and then you must minus the square. So this is going to be p squared over 4, and then that plus 4 is still there because that is not part of those 2. Okay, so that is the important thing that we must understand, that it doesn't matter what we have now, we can apply the method of completing the square. So the x comes in there, exactly the same sign, that 1/2, square it, minus that one, the square, so p squared, 2 squared is 4. Now we can just take these 2 to the other side, so we have x plus p/2 squared, and on the other side we're now going to have p squared over 4, and then a minus 4, which we can put over 4. common multiple, which is then p squared minus 16. Okay, now we can apply the square root property. So x plus p over 2 will then be plus or minus the square root of that whole thing. P squared minus 16 over 4. Now remember, the square root of 4 is 2. So this is actually plus minus the square root of p squared minus 16 over 2. Okay, because the square root of 4 is 2. Okay, and then I can move over my p over 2, so I just have x on that side. So this is going to be minus p, and because that is also over 2, I can put everything now over 2. Okay, that 2 is a bit ugly. Let me put a better 2 there. And then this is plus minus the square root of p squared minus 16. Okay, so once again, we need to understand that in mathematics that we must be able to apply a rule under more difficult circumstances. So now, because there's a p, it doesn't mean that now you can't do this. So you know you need to divide that middle one by 2. Then you need to square it and subtract it. If you understand that law, then it's easy. And then we have to move it over to the other side. We just put it on the multiple there. Then we applied the square root property of plus minus the square root of everything on the right hand side now. The square root of the top I cannot find, but the square root of 4 is 2. Therefore it's plus minus the square root over 2. And because this is also over 2, if I move it over, the minus p is just going to be at the top. I still put everything on 2 on the multiple 2. That's 2 there and it's 2 here, so everything is just on 2. So this is going to be then my final answer for completing the square with an unknown, which we must also be able to do, especially in AP Mathematics. So I hope you understand how to complete the square.